This video provides a comprehensive visual guide to activation functions, how to understand, diagnose, and choose activation functions for deep neural networks. Neural networks use activation gateways to serve the same role as the brain in filtering out noise and irrelevant data, retaining only essential information for calculations. An activation function is the mathematical function that determines whether a signal should pass. It processes the weighted sum of inputs and bias to produce the output. Feed-forward propagation is the flow of information for output calculation from layer to layer. Backpropagation adjusts weights to minimize cost, requiring a proper gradient to learn. Why do we need nonlinearity? Using only linear activation functions, deep networks collapse into a simple linear regression model, failing to learn complex tasks. Vanishing gradients occur when the derivative becomes very small, halting learning. Exploding gradients involve large, unstable weight updates that can lead to calculation overflows. The first family, the baseline, includes the linear function, which is prone to layer collapse, and the binary step function, which has a zero gradient and cannot be used for multi-class classification. The second family, the smoothers, includes ton and sigmoid functions. Ton is preferred as it is zero-centered, but both suffer from the vanishing gradient problem for extreme values. ReLU is an engineering breakthrough. Its non-saturating gradient accelerates convergence and simplifies calculations. However, it can suffer from the dying ReLU problem, where neurons may stop updating forever. The third family includes fixes for ReLU. Leaky ReLU and parametric ReLU address dying neurons by assigning a small or learned slope to negative inputs. ELU provides a smooth, zero-centered curve. The fourth family, the modern NLP heavyweights, includes SELU for self-normalizing networks, JLU for large language models, and SWISH for very deep networks, outperforming ReLU. Softmax is the output gateway, transforming a set of raw scores into a probability distribution that sums to 1. It is the standard activation for the final layer in multi-class classification problems. Choosing the output layer function depends on the prediction type. Regression uses linear, binary classification uses sigmoid, and multi-class classification uses softmax. For hidden layers, always start with ReLU. Use ton for recurrent neural networks, SWISH for very deep networks, and GLU for large language models. Avoid sigmoid or ton in deep layers to prevent vanishing gradients. This table serves as a comprehensive reference guide for various activation functions, illustrating their characteristics, best use cases, and preferred locations within a neural network.